All right, so this is the second page of 4.1, day 3. We're still using our calculator to deal with polynomials. Now we are going to use it to find a polynomial regression. So in order to do any type of regression, we need to get our data in our list. So it says the following data represents a percentage of families in the United States whose income is below the poverty level. So they give us the years from 1990 up to 2004. But we are going to adjust it. We're going to make 1990 be year 1. And we are going to use these years, these steps as 1, 2, 3, 4, and so forth instead of the actual year, just so it's a little bit easier for us to graph. Or else, if we didn't, our x-axis would be like 1990 up to 2004, and those are just really big x values. So to put this data in my list, I'm going to go to Stat, Edit, and I'm going to go into my list. If you have data here, go up to L1, press clear, and enter, and it'll delete it. Same thing for L2 if you have it. So I'm going to go ahead and put this data in. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So it's every year from 1990 to 2004. I'm going to put my levels in, my poverty level, so 10.9, 11.5, 11.9, 12.3, okay, so there's my data. To create my scatter plot now, I'm going to go to second y equals. So second y equals gets me the scatter plot. I'm going to press enter. I want to turn this on. All right. And then this is the scatter plot, so I leave that there. My x list is L1. My y list is L2. And then just the other thing to note, if you go to y equals, this equation's still here from before, so we're just going to clear that so it doesn't show up. And now, when we normally graph, we do zoom 6 for standard. But if we keep going down to zoom 9, it will automatically preset it based on what that scatter plot's going to look. So I'm going to zoom 9, press enter, and here is our data. So just quickly rough sketch it. So something kind of like that. So there's a scatter plot. And obviously this looks like some type of odd degree polynomial, right? Because I'm coming up, down, and up. So my ends look to be like that. So I'm going to be some odd degree polynomial. So I can actually plug in a regression model for it. Now they'll always have to tell you what type. So they're telling you, hey, it's a cubic function, okay? So I'm going to go y equals, well, we'll just get the cubic function first. Go to stat, calc now, and then table down to find cubic regression. Press enter and calculate. And this is our equation. So y equals 0.00952x cubed minus 0.219x squared plus 1.185x plus 10.008. All right, so that is my equation. And if I want to and then I can use this equation. So I'm going to do two things. First, I'm going to put this equation into my y equals. So if I go to y equals and do the same thing, stat calc, cubic regression, should put it in there. On these new ones, if you're in the old calculator, if you do that, that will work. If not, if you're in the new calculator, when you go there, when you say store regret, like REGEQ, I can actually click where to store it. And I want to store it into y1. So to get that, I click vars, yvars, function y1. And now when I calculate it, it goes right into there for me. Okay? So now when I press my graph, you can see that line of best fits coming in. So something along those lines. The reason that I want to draw the function is because now when it says use the model found in number 2 to predict the percentage of U.S. families that were below the poverty line in 2005, or where T is 16, I could plug 16 into this equation, but there's a lot of decimal points, and I rounded them. So to get a more precise answer, I can do two things. I can go second calc. I have an x value, right, or a t value in this case, which is 16. So I have a value. Press enter, and I can press 16, and it gives me the predicted value. So it's 16 comma 11.78. So in 2005, you estimate approximately 11.78% will be below the poverty line level. Poverty level. You could also, instead of typing the value, you could go second graph to get your table. And now I can table till I find 16, because it's a full number. And I should get that same thing, 11.78. So that is how you use regression, or how you do polynomial regression on the calculator.